Welcome everybody to another one of James's video. We're now going to be dealing with type 2 of the setting up of a triangle of the trigonometry section, and that is when an equation is given. Okay, so if you guys are following on from the first video where we did when a point is given, we're now doing type 2 of a setting up of a triangle when an equation is given. So let's read the question. If 3 sine theta equals 2, with theta being an element between 90 degrees and 270 degrees, calculate without using a calculator the value of tan of theta, number 1 over cos theta, number 2, and tan squared theta plus 1 over cos squared theta, number 3. Okay, so how do we approach this? There's a few extra steps needed when an equation is given. 2 extra steps to be more specific. So the first step, so let's just maybe put steps here. Step 1, we need to take our equation and simplify it so that we have a trig ratio on one side equal to a fraction or a decimal. So therefore, sine of theta equals 2 over 3. How did I do that, guys? I divided both sides by 3, okay? So all I did was I divided this by 3, divided this by 3, okay, to get sine by itself. The reason why we do that is because obviously we know then that sine is a ratio of sides. So we already know that this is my opposite side and this is my hypotenuse side. But that'll come later when we're doing our triangle. But I just need you guys to know why we are doing that step. Now, step 2 is to work out our quadrant. Okay, so step 2 is working out the quadrant we're going to be constructing this triangle in. So how do we do that? Well, we first start off by drawing a mini cast diagram. And we take 2 things into consideration. We take into consideration the sine of your trig ratio. And I'm going to highlight that to show you what I'm talking about. And the second thing we take into consideration is the domain / restriction given. Okay, so let's use some color coding here. Let's use blue. So the sine of the trig ratio, let's make it green. Do you agree with me that the sine of this trig ratio is a positive? Sine of theta is equal to positive 2/3. Okay, so that is the sine of the ratio. That tells us a quadrant. Now, where is sine positive, everybody? Sine is positive in the first and the second quadrant. So I'll tick those 2 quadrants. The second thing we look at when determining the quadrant is the domain or the restriction given. And I'm going to highlight that in blue. And that is normally given to you in the question. So in this case, that is our restriction. Theta is an element between 90 and 270. So remember, which quadrants are between 90 and 270? Let's just give our quadrants degrees here. So which quadrants lie between 90 and 270? Your second and your third. And very simply now, guys, where do I have 2 ticks? I have 2 ticks in my second quadrant. Therefore, that is where I'm going to be constructing my triangle, which is now step 3. Step 3 is drawing. Okay, so let's draw. We are only going to be dealing in quadrant 2. You draw a line from the center, and then you put your point there, and then you drop a line down to the horizontal axis. Always, guys, we will never do that. Okay, we always drop our line down to the horizontal axis, to the x-axis, to create our right angle triangle. Our theta that we're dealing with would be this. And remember, I told you earlier that this is the opposite and this is the hypotenuse. Well, we can put that in, surely. So opposite to my theta will be 2, and hypotenuse is going to be 3. Okay, so the only side that I need to work out now is my adjacent side. And how do we do that? And that comes to step 4. Step 4 is Pythagoras. So we're going to have to work out our adjacent side. So I'm just going to say here, h squared equals opposite side squared plus adjacent side squared. So my hypotenuse is 3. So 3 squared equals 2 squared plus my adjacent side squared. Running out of space here. Okay, and then we're going to bring this over. So 9 minus 4, I've just done those squares quickly. adjacent side squared. We're then going to square root both sides, and that is going to give me the square root of 5 equals my adjacent side. But a little bit more specific, it's going to be a negative. Remember, guys, when we square root, we get a plus minus result. But what side? Remember, we're still dealing with an x and a y axis. So if I'm constructing a triangle in my second quadrant, it means that my y values will be positive, but my x's will be negative because I'm on the left-hand side of the y-axis. You see that? Or the left-hand side of the x-axis, should I say, from the y-axis. So it means that we're going to have a negative root 5 here as a distance. Okay. Everyone understand that? The quadrants matter because they will tell you the signage of your x and your y distances. Hypotenuse, guys, will always be positive because you are squaring and then adding. Okay, fantastic. So step 5 is now to answer the questions. Okay, so now we're going to use our triangle, and I'm going to do it on the right here. I'm going to say step 5 is questions. Okay, so let's see what our first question is. Tan of theta. So we're reading our triangle now. Tan of theta is opposite over adjacent. So my answer for tan of theta would be minus 2 root 5 over root 5. Okay, step 2. We're looking at, or not step 2, we're looking at question 2, 1 over cos theta. Okay, so what we're going to do here, we're going to look at our drawing. 1 over cos. Cos is adjacent over hypotenuse. So we're going to say 1 over minus root 5 over 3. A little bit of fraction work here, guys. When we're dividing a fraction by a fraction, we can invert and flip the fraction. And that's going to become minus 3 over root 5. Okay, that's a flip times, or it's the divide flip times technique. Okay, number 3. We then have to do, let's see the question, tan squared theta plus 1 over cos squared theta. Okay, using our triangle, let's answer this question. So tan, we know, is minus 2 over root 5 squared. Let me be a little bit more specific there so I'm not confusing people. The negative is actually in the middle of the fraction. Okay, like that. Okay, plus 1 over cos squared, which is actually the above question, isn't it? 1 over cos is minus 3 over root 5. So 1 over cos squared, let me just show you guys what I mean here. That is the same as 1 over cos theta squared. So I can actually change that. I can say that it's going to be minus 3 over root 5 squared. And then when you're timesing, let's times this out. Negative times a negative is a positive. 2 times 2 is 4. Root 5 by root 5 times root 5 is 5. Plus 9 over 5, which is going to give me 13 over 5 as my final answer. Okay, so that is an example of setting up of a triangle type 2 when an equation is given. Let's just run through it, just a quick summary. Step 1, simplify your trig ratio into a trig function equaling a fraction or a decimal. Step 2, working out your quadrants. The two things we take into consideration is the sign of your trig ratio as well as the domain or restriction given in the question. Step 3 is to draw your triangle in that quadrant you worked out in step 2 and then put in your known sides. Step 4 is to use Pythagoras' theorem to work out your third unknown side. After that, all your information in your triangle is sorted. We can therefore go on to step 5, which is answering your questions, which is a little bit of fraction simplification work. Okay, hope you guys all enjoyed this video. Type 2, the next video will be type 3, where we have another equation, but it's a different type where we have unknown sides but known angles. Okay, so have a fantastic day, and please look out if you are keen on seeing more videos. Please click the subscribe button, and we also have a James book for sale that contains all the notes that you see here. So if you're interested in purchasing one, please comment in the comments below, or just drop us a message and we get in comms with you. Fantastic. Have a good day. Cheers, guys.